Well, today we're going to look at areas. This time, though, it's going to be a little more complicated because we're going to area between two shapes. So, for instance, let's just dive right in. Here's a problem where we're trying to find the shaded region. The shaded region is this darker frame, almost like a picture frame, if you will. Now, we could break this into a bunch of little rectangles, right? We could slice it up all these different ways. You know, that would work. But turns out what's going to be a lot quicker and easier is to think of this as being a bigger rectangle, which in this case specifically a square, and then we're subtracting the inside, right? So think of it this way. Think of a big square which is taking up this whole region, right? Like you got a piece of cardboard. And then what we do is we cut out from inside of it this region I'm highlighting in red, right? Just the point inside here. So just figure out the total area, subtract what's inside of it, okay? All right, so in other words, if you were to think of it as two squares, you've got a bigger square here, and then we're subtracting a smaller square from inside of it. Smaller square from this bigger square. Okay. All right. Well, again, just to keep track of things, I find it's really handy. Just use some labels here, right? I'm going to call this big square A, and then I'll call the little one B. Now, again, this A is referring to everything, right? So I'm calling this A, and I'm going to call this part B. Okay. Well, that's just the formula for the area of a square. Now, that's pretty easy, right? It's just sides squared. So here, this guy's 29.7 kilometers. Notice they're both kilometers. We'll make sure to bring those units back at the end. And so then I just have to say for A, the bigger one, I've got 29.7 squared. And again, I'm subtracting here. I'm going to subtract the inner one, which is just 19.5 squared. Now, when I expand that and do the work, I end up with 29.7 squared, which is 882.09. The inside is going to be 380.25, right? So this, again, this is 882 square kilometers. This is 380.25 square kilometers. And you finally get an answer that's 501.84 kilometers squared. Now, let's double check that we did this right. Now, it says write your answer as a whole number or decimal. Okay, decimal rounded to the nearest hundredth. Okay, well, that's nearest hundredth. Just worked out, but we are going to have to worry about rounding for some of these problems. In particular, let's take a look at this next problem here, which now we've got a couple of triangles, right? A couple of triangles that are forming a shaded region. Now, this time, right, again, we'll think of it the same way we did a second ago. So I'll think of this big region right here, the bigger triangle, and then I'm going to subtract a smaller triangle from inside, right? Just shade that. That's this area in here, but just the smaller one, okay? Well, so this time we're using the formula for triangles. And again, just keep track. I'm going to call this outer one A, this inner one B, okay? So I've got A, region A minus region B. Well, if you remember, right, the area of a triangle is 1/2 base times height. Now, they didn't say it, but I think it's a pretty safe assumption that these are right triangles. I'm just going to base it on the fact that these were right triangles. Again, A is just 37, 36, right? So we would have just the formula of 1/2, right, base times height, minus 1/2 base times height. Now again, this is base of A, height of A. This is base of B, height of B, right? Just so we don't think they're all the same number. So again, this is 37 and 36, right? 1/2, 37, 36 minus 1/2, 20. And this one, they're both 20, okay? So once we do all that, we're going to work it out, and this is just 666 square meters. This is 200. You subtract them, you get 466. But again, make sure you talk about your units, right? This is meters squared, or sometimes people would actually write that out and say something like square meters, right? So you could say it that way too. Okay. All right. And again, doesn't look like we need to round or anything, so that one just ends up being just like that. Okay. Great. All right. Now we're going to up our game a little bit. Now we got some circles. So this is a little like a washer, you know, like you'd use for using if you had nuts and washers and you were fastening some metal parts. Now, you know, and if you were designing a washer, you need to know how much weight there was in the object. So this is actually the kind of thing you actually would have to calculate if you're designing hardware. You know, figure out how much things weigh, how much metal you're going to use. Okay, now let's think back about how we find the area of a circle. Okay, we're going to do the same thing we had here, right? We're going to have an outer circle and an inner circle. Okay, but in general, remember the area of a circle, the formula is pi r squared, right? Remember, pi is about 3, so it's like 3/4 of 4 by 4 square, right? Right? If you ever can't quite remember the formula, just remember this real quick, right? Here's this 4 by 4 grid, circle inside. Each of these little boxes is r squared. The circle is about 3/4 of it. That's why it's pi, because that's like 3. Okay. All right, so let's now use it. Well, we're going to need to know the radius. Now, we're going to have to start getting creative here. And again, I love these kind of problems where you got to think a little bit. It's kind of like a puzzle, a little Sherlock Holmes action here. So first thing we need to do, now this one's pretty straightforward, right? Now it's giving me the diameter. I really want the radius, don't I? So what I'm going to do is I got to think of this distance from here to here, 38.4. Well, half of 38.4 is just 19.2. Okay, that's pretty good. Now let's think about the bigger radius. The bigger radius is going to include the 9.6. All right. Well, if we want to include that one, right, we're going to come way up here. We've got 19.2 plus 9.6. Well, 19 plus 2 plus 9 plus 6, that's going to give you 28.8. Okay, we've got everything we need to know now, right? Now you notice really helps. You're going to want to write this stuff down. Do not try to do this in your head. You got to get some paper. It's the only way you're going to be able to get these done. Okay, so now let's actually calculate it. Now again, we're going to have the one circle minus the other circle. So just to remind ourselves, right? I've got pi r squared minus pi r squared. Now these are different r's, right? So again, I'm going to call this outer one, right? We'll call this A, we'll call the inner one B. So that means this is R sub A, this is R sub B, right? So these are not the same radii, are they? Okay, and so now we just get to start substituting everything. So I get 3.14, and what you notice is most of these problems we're just going to assume 3.14. That's a pretty common approximation for pi, but just to be clear, it is approximation. You know, it's not perfect, but probably most things you're going to need to do in your life, that's going to be close enough, and you're going to be really happy with the results. Okay, so I've got r sub a squared. R sub a squared. Now again, we've got 28.8, the whole thing squared. Again, minus 3.14, 19.2 squared. Okay. All right. Now, when we multiply all that out, what you're going to get is you're going to get a big, messy number. It's just, you know, there's no way to avoid it. It's just what's going to happen. So here it goes. I've got 2604.4416 minus 1157.5296. Okay, now the reason I'm showing you all this is, you know, yeah, you could probably do this on your calculator, but I strongly recommend you write down some of these intermediate steps just so you get it straight. And when we subtract those, you get 1446.912. Now, I didn't show you this because I needed the space on the page, but kind of like the problem we had earlier, this is actually asking to round to 100th. That was actually the instructions here, but it was kind of getting in my way, so I took it off here. Now I need to round this, so my final answer is actually 1446.91, and this is going to be square inches, right? Or you can also think of it as inches squared. Now, one thing I want to emphasize here is round at the end of your problem. Notice I could have thought, well, maybe I'll round here, right? Call this 44, call this 53, right? Now, when you start doing that, if you try to round too soon, sometimes the way things round, they fight each other, and you end up with a less accurate answer. So you're really better off waiting till the very end to do your rounding. So again, that's a really important thing, especially when you've got big numbers like that. Okay. All right. So again, just to rehash this one, right? What we had to do, we knew we needed radius. So first, find the radii. Again, if you don't have this on your paper, you're going to want to sketch this picture, right? So make sure you got, it doesn't have to be perfect, but just somewhere nice and big. Notice this is pretty big size here. You need a nice big picture to write your numbers down. Don't make a little tiny one, okay? Paper is cheap, just do it the way you need to do, okay? Now, let's look at this last one here. For this last one, same kind of thing we had to do here, right? And again, here, rounding to the nearest hundredth. Remember from that last problem? But again, I need to find the radii. Now, in this case, well, I can see I've got this little dimension up here, so that's good. But this time I only know the circumference. What I really need to find out, though, is I really want to know what this radius is, don't I, right? And again, let's call this inside one B. Let's call the outside one A. Okay. Right, so I got to find R sub B. Now, I do know the circumference. Well, we have our formula for the circumference of a circle, right? And if you remember, if you can't remember the circumference of a circle, just grab your pen, right? Count it out. Okay, that's a diameter, once across, twice, 3, a little bit more, 3.14, right? So the formula for the circumference of a circle, right? We're going to use this here. We've got circumference equals pi times the diameter, right? Now, that's not really what we want because we're trying to find the radius. So I'm going to actually use the version where circumference equals 2 pi r, right? The diameter is 2 r's, right? We kind of split it with the pi in the middle. That's just what people do. But I'm actually in the opposite direction, aren't I? I know the circumference. I'm trying to find the radius. So I'm actually going to use the version where I divide both sides by 2 pi. So actually what's going to be helpful here is radius equals circumference over 2 pi. That's the version I want to use today. Because again, I know the circumference, I want to find this radius. Well, okay, so let's be specific. R sub B equals circumference over 2 pi. Circumference is 157 to 3.14, okay? You plop that into your calculator, right? And technically that's an approximation because it's 3.14. And that's going to give me a radius of 25. So this is 25, okay? My bigger radius up here is 25 plus this 11. So this one, R sub A, is equal to 25 plus 11. So that's just 36, right? Okay, and then we're going to do the same thing we did previously. So we're going to pi r squared minus pi r squared. So I'm going to have 3.14. So right now this is the outer circle here. 36 squared minus 3.14 times 25 squared. Okay, same kind of thing. You're gonna find out. I'm gonna get 4,069.44 minus 1962.5. When you subtract them, you will get 2106.94, and that, again, make sure you use the units, is millimeters squared. Now, it was hundredth. That's actually the way it turned out, so I didn't do any rounding, but this is how you do the last problem. All right, so again, big takeaway, use paper, okay? Big thing to remember, use paper, round at the end, Okay. All right, guys, that's it for today. We'll see you in the next video.